right, we're in week 3. We've witnessed our game reveal that previous week, so I hope you guys have all gotten a chance to see it, because we are going to be doing a brief bit about this year's game changeup, as well as talking a little bit about some early season stuff this STEMinar. So stuff that's like a little bit more focused on the early season, because we are now in the early season. That's what we're going to kind of focus on in this STEMinar. So, for those of you who are new, again, welcome to VRC VEX, a strategic approach. If you haven't seen any of the previous seminars, I heavily recommend you do go to our YouTube channel and watch them, just because these kind of build on top of each other. So it's really beneficial to watch all of them instead of just like one, because they did cover different topics every time. So my name is Afnan. I'm going to be presenting. Nate is also with me here today. He's pretty cool. Nate, if you want to go ahead and share some of the stuff that you do, or, talk a little bit just so they can hear you.
Just briefly, hi, I'm Nate. I work at the Fab Lab. I currently work with 3D printing, and I also teach the 3D printing and 3D scanning seminars.
Yeah, so it's pretty cool. Thank you for joining us today. Thank you for helping out.
Thank you for having me.
Yeah. So, Nova Systemic as a whole is pretty cool. We do a lot of stuff, like we're doing these seminars today. And as Nate mentioned, he also does the 3D printing seminar. So there's a lot of different content, a lot of different stuff that we can do. We do summer camps, and I have gotten some updated notice about those summer camps that I can kind of fill you guys in with. We have robotics tournaments that we're doing, as well as just any general STEM. So on the note of that summer camps that I made a second ago, I got an email earlier today from Jose, actually, who runs a lot of our summer camp stuff. And he mentioned that, we have officially decided that we are going to be doing our summer camps, a lot of them online in a sense. Let me see if I can pull up my email real quick. All right, yeah. So as per what Jose is telling us, we're going to have our summer camps that are going to be shifted to online, and we're going to divide our summer camp curriculum up into about 3 different main parts, which is going to be programming, coding, design and engineering notebook, and then game analysis and strategy. And so, I think I'm going to be the one who's going to be working on the summer camp for game analysis and strategy. And essentially it's going to be a mixture of recorded sessions and kind of Google Classroom style meetups. So, it'll have some recorded sessions and some recorded videos that you can watch, as well as having some direct instructor guidance there. So, those summer camps are not available for registration just yet, but they are going to be coming out soon. So hopefully by next week, I'll have some more information on that for you guys. And yeah, if you have any questions, feel free to ask systemic@nvcc.edu, just so we can address anything that you might be, wondering. All right. So our overview for today, our overall goals are going to be, learning how to break down a VEX game, learning how to form strategies, practicing critical thinking, our approach, same as always, breaking down a game, reading some rules, watching some gameplay. So today in particular, what we're going to be doing is we're going to focus on team workflow. We're going to look at this unique season that we're in right now. We're going to briefly look at changeup, maybe have some discussion if we can, and then break down a game. So I hope you guys are ready to kind of dive into that. We are going to have some discussion at the end and a little bit of general Q&A. I don't know why that's there. That's awkward. All right, so team workflow. So workflow is the process of how work gets done. So, it's more than just screwing things together. It's like, how am I going to go about screwing these things together? What am I actually going to do, right? So there should be some management in how you do your work. So there shouldn't just be like a bunch of people randomly doing things. That's what a lot of people tend to do, is just hop in, go to a meeting and they just start working. And although that does work sometimes, it's not going to be as productive, not going to be as beneficial as being more meticulous and more methodical in the way you do this. There should be some sort of process, some sort of structure that you follow when you want to do work. So, just to kind of get think about this season in particular, we specifically can't do that now. We specifically can't just start meeting together and start working and start putting stuff together, right? We have to be socially isolated and such. So we can't have those large gatherings. We can't kind of come together. So we definitely wanted to be more meticulous this season in our time usage. And one reason we want to always have a good established workflow is because it's great for our documentation stuff, right? Anything you do in terms of your team workflow, any sort of overhead, any sort of management is great for your documentation, because that creates, finite steps that you can follow, that you can kind of document the process with, and have a lot to kind of talk about and have a lot of good stopping points for your documentation. So if you do it right, it'll save you a lot of time. I've definitely had teams where I've been doing work in. And so we just kind of do work, spur of the moment. We say, hey, we need to get this done. Let's do it. We need to get that done. Let's do it. And we end up realizing that either there's always one person who's just kind of chilling on the side, doesn't really know what they're supposed to be doing, or we waste a lot of time and just and get off topic, right? So without the workflow, you tend to lose track of, what is the next step in my immediate process of the design of, like, whether it be the immediate process of building a part or whether it be the process of the overall design, process. So there's that. It's a great life skill. So being able to have like a good team workflow, super useful, super like useful life skill is understanding how workflow works. All professional working environments do have their specific way that they do work, right? Whether it be, you have to submit a request to install some program, you have to call IT and they got to install a program, whatever it might be, there's a specific process for it. And so getting used to the idea of, creating specific processes and channels to get work done through is really useful because, after robotics, you are going to have to live your life as well. After, it's unfortunate, but after you get out of all the robotic stuff, there's going to be more work to be done, right? So becoming familiar with some of these, workflow tools and being able to work in that type of environment that uses a specific workflow, super beneficial for you. So a quick example of workflow would be, if somebody has an idea, that's step one, just having the idea. All right, let's take that idea, let's document. These were the ideas we had. Okay, we take that idea and we share the idea. All right, so now we can document that brainstorming session we did together. What did I say? What did they say? How does it come back? How does it go around? What are the other opinions? There we go. We get our feedback, right? So now that I say, hey, I think I have a super cool idea for a robot, it's totally going to win, but it doesn't need wheels. I think wheels are a bad idea. Wheels, super unnecessary waste of motors. And someone goes, well, did you think about, maybe you have to move to get these points? Did you think about maybe, you have to be able to be dynamic? And I go, oh, that's a correct point. I didn't even think about that. So, that feedback I got was on my idea, although I thought it was a great idea. I still documented the idea, but I also was able to document the feedback I got and say, oh, this is the process I followed. And I went from an idea that's kind of okay to an idea that's even better. And kind of following suit with that process is how we get from point A to point B, right? Where point A might be the beginning of the season, point B might be a world championship. So, team decides that we go with idea. Okay, cool. So in my documentation, I now say, hey, this was my idea. These were other people's ideas. This was the collective feedback we got. And, the team voted, or the team did a Gantt chart, the team did whatever. And it looks like the idea we're going with is having wheels that are 3.5 inch big. All right, cool. So now I can justify that decision I made, right? Because I have all my feedback and I have the consensus of the team. Everyone now knows we're on the same page. Everyone knows what type of wheels we're going with, and everybody knows why we're going with them, right? And also importantly, the documentation knows why. The decision that you chose 3.5 inch wheels, 4 inch wheels, 2.75 inch wheels, that wasn't just randomly decided. There was a discussion about it. Active decisions were made. Active input was, given. And we decided that the best decision, because X, Y, and Z, is that. So having that team workflow is kind of getting you like those finite steps on, like a staircase or a ladder, something to get from the bottom to the top. And then now you make idea sketches. All right, cool. Now we have those idea sketches. I can kind of put those in my documentation as well, right? I can say, well, here was the idea that I had, and here's the idea that she had, and here's the idea that she had over there, and here's the idea that he had over there. And, getting all those sketches together is that early brainstorming part in the design process. And it's super good for your documentation because you can now provide a literal to the contextual examples you're providing. Like, oh, I think we should be able to score really quickly. This intake that I drew lets us do that. It's kind of like getting from step A to step B. Additionally, getting that sketch approved by the team is then that next step that you can document and saying, hey, well, here are all the different sketches we had. We decided that, we wanted 3.75 inch wheels, but we didn't know where we wanted to put them. So we did a few sketches and, we said one at the very front, one at the very back, one in the middle, maybe a little bit of offset. And, after looking at all those sketches, we decided on having them at the very front. And so now in your documentation, what you can do is you can say, okay, here are a few examples of the different implementations we were considering, and here's the final implementation we went with. So now you've got everything from, the different ideas you had to the one you picked, and the different implementations of that idea you had to the one you picked. You're now going from a really wide to a very narrow, and doing so in a process that lets you document every step of the way and have input from the team. So it's a team decision to do that. Once you've got that, okay, you've got your drawing, you can now begin your prototyping, right? So you can say, hey, let's get CAD going, or let's get some metal going, and let's try it out. All right, well, I made my prototype. Let me test my prototype now. Let me see what the team input is on the test. Let me see what the data is. It's one thing to just say this is the best idea you've ever had. It's another thing to prove it with the objective data, right? Because data doesn't really lie in that sense. You can think something is fast, you can think something is slow, but the objective fact is, it takes 2.5 seconds to get from point A to point B. And that's not your opinion. That's like literally the fact of what it took, right? So you can now compare these facts instead of, well, I think this is kind of fast, but not really fast. You know what I'm saying? So it definitely avoids that type of confusion area. Also, once you've got that prototype, you can now begin just iteratively improving on that prototype, because that was the best decision you've made, going from wide to narrow, and now you're just working with it. You're right. You're working with iteration A, iteration B, iteration C, maybe all the way up to Z. But Z might be that best idea that takes you to the world championship. So it's worth it. Definitely worth it. All right, so useful tools, right? So these are some useful tools for workflow. You might be familiar with a lot of them, you might not be. What I'm gonna do is I'm gonna kind of list them out, and then I'm actually gonna go and show you some of these tools that I've used, right? So useful tools, Trello. So Trello's like our work management tool. It's kind of like how you can assign tasks to other people and how you can kind of calendar things out. It's not, maybe not specifically Trello, but similar programs are used throughout the industry to kind of assign tasks to people and to kind of make sure people are keeping up to date with what their requirements are. We've got Slack. So for those of you who are not familiar with Slack, Slack is similar to kind of like Discord, but it's considered a little bit more professional, right? So if you want to use Discord, that's fine. I personally prefer Slack a little bit more, but they're essentially the same, use case where you have a team that needs to work on a project. You have separate channels to do communication about the separate aspects of that project. And then, everyone can kind of be in sync following the messages. What this avoids is huge email chains. And it's the one thing that I'm not a huge fan of is, whether it be coaches or whether it be students sending a huge email and then someone hits the reply all. And I really didn't need to know that you said thank you, but in a reply all sense, right? Like, it's kind of obnoxious, but it definitely avoids that. It also allows for, any point in time, instead of like searching through email chains, you can just go on, autonomous channel. Okay, let's look at the previous videos that we uploaded here for the autonomous. It kind of becomes like a living document that can go inside your engineering notebook, right? So any point in time, if you go, I forgot what we were doing on June 10th. Well, you can go back to your Slack, you go back to your Discord, you say, hey, in the documentation channel, we require that everybody sends 3 pictures a day in the documentation channel. Let's select the documentation channel. Oh, okay, yeah, so here's a picture of the lift, here's a picture of it going on, here's a picture of what it looked like after it was done. So now you can instead of trying to have to remember or search through people's photo album in their phone, you have one central location that stores all that information, right? So that's pretty useful. Additionally, we've got Git. So if you're not familiar with Git, that's like our code revisioning tool used for people working in mass with code. So if you have a project where you're not the only one touching the code and you definitely want to have a backup somewhere, it's very useful to be using Git, right? Because that'll allow you to, one, have your version of the code, upload your version of the code, have other people pull your version of the code, edit it a little bit, and push it right back. So you can kind of collaborate in that sense without having to say, here's the flash drive with the code on it. Oops, did you lose the flash drive? Oh no, now we've lost all your code. Or 2 years later, you say, oh, this game really could use some line following. I think line following would be really good. And now you have to think back, well, we did line following 2 years ago. Does anyone have that code? And now people are checking their emails, people are checking their flash drives, where's that code? Having Git repositories are super useful for, having all that backed up. So there's our Trello, there's our Slack, and there's our Git. And I remember Git is the most broad term. You can have GitLab, GitHub, or whatever other repository system you want. At the end of the day, they do the same task. And so let's briefly for a second go into Trello. So here's a really old Trello page from like 2015, from when I was in high school, just about like what we did. So what you'll notice is, we've got a backlog, we've got a next, we've got an in progress and completed. Every task, for example, our autonomous has a checklist, right? So we first want to create our backup autonomous. All right, we can check that off. Then we create the autonomous for the blue tile. We test that autonomous. We create the autonomous for the other blue tile. We test that autonomous. Create autonomous for both red tiles or for the red tiles, right? So now I can check that off and I know that it's 100% done. Additionally, members, I can just click here and say, oh, hey, Anders, it's your job to do that work. Or, I would need this due by a specific date. I can assign a due date, right? Having a due date assigned, having specific members assigned, lets everybody know that, hey, this job was your specific responsibility. It was your job to get this done in 10 days. And, looking at the checklist, you got halfway done. Now you can directly track what you're doing, right? You can directly see how stuff is going. It also prevents people from being confused. I've had so many projects that I work on, whether it be school projects or robotics projects, where, we're a week away from the submission and someone goes, hey guys, I didn't really know what I was supposed to be doing, so I just didn't do anything. And that's kind of like, are you kidding me right now? We got a lot of work to do. Time is very valuable. You definitely want to you want to take advantage of all the time you can And, having that structure of, hey, well, we formally assigned you this task and you formally were assigned that task. That is super, super helpful, right? Because no one's ever confused as to, oh, I was supposed to get driving practice. I thought they were supposed to get driving practice, or I thought she was working on the code. I thought he was doing that. Definitely makes it a lot easier. Additionally, we've got a little cards. We can just click and drag these cards whenever we're done. So whenever, let's say that something is in progress, our new intake is in progress, we understand the basic design of our new intake. We ensure that it's compatible with the intake design that we already had. Make sure the base and ARM work with it. Make at least 3 prototypes to choose from. Choose our prototype. Improve on the chosen prototype, and then implement a refined design. Right? Those are all the steps of the design process, more or less, or important mile markers we want to do. And then we can check those off as we get there. Once it's done, we go on to complete it, and then we pick another thing off the backlog, and the process continues. Right? So maybe like every meeting, we go, hey guys. What did you get done? And, oh, I see that, so-and-so, you were assigned the autonomous. Did it get done? And they say, oh, I got halfway there. I might need another week. All right, cool. I can add another week to the extension, or I can keep it behind so we can reflect in our calendar or our Gantt chart or whatever it might be, how far behind we are. Right. So let's see. Here's an example, driving practice, right? So driving practice, be able to pick up one ball in 15 seconds. All right, we can do that. Now let's move on to picking up a ball in 10 seconds. Okay, now let's move on to pick up a ball in 4, in 3, in 1. Having all these mile markers formally lets you know that you're objectively improving in your like driving skills, right? You're not just kind of like, oh, it's time to practice. You're not just messing around on the field. You're not just kind of aimlessly driving and scoring. There are specific things you're trying to achieve that make you better at doing something, right? You generally do get better the more practice you get, right? So just driving around is beneficial, but if you change that to having a structure to why you're driving, you're not just driving around trying to score points. This time you're trying to understand, what is the best way to score points. Take an example from Tower Takeover this year, right? Let's say that you did a bunch of practice and, you put a bunch of stacks up and, you're doing pretty good, but you never took 5 seconds to say, hey, well, how much time does it really take us to put up the stack? It takes us 10 seconds to put up the stack. Is that a lot? Is that not a lot? You might have to do some tests to push the limits, right? You might have to say, okay, let's see if we can put up a stack in 5 seconds. Let's see if we can put up a stack in 7 seconds. Now you get some sort of baseline for what that design can do. And in your documentation, you can objectively say, hey, well, this design was only able to put up a stack in 7 seconds. And, that was 2 months ago, but we totally changed the design. And now the design is able to put up a stack in 5 seconds. All right. Now what do you have? You have objective proof that your design decision was correct, right? You can objectively say that my previous design, although it was good, only achieved this much. My new design achieves so much more. It can do so much better. And here's the data to back that claim up, right? You're no longer just saying we randomly changed because woohoo. You're objectively telling people why the decisions you make are the decisions you make. And that's what takes your documentation so much further, right? Being able to explain why you're doing what you're doing. So, that's a brief kind of what you might do with like some sort of Trello usage. We've got Slack. So, this is for a hackathon organized, but essentially, same thing as your Discord might be. You've got, oh, everyone who's working on the website, please be in this channel. And, what are the updates from the website on October 15th, 2019? I can read them up. I can see what's going on. Here's the reflection. maybe after every competition you attend, you want to do a competition reflection. And it would be a great place to host that right there, right? We can have, for social, like for all our social media, so everyone can know, hey, well, our Instagram is getting messages. Let's make sure we respond to them. Our Facebook account's getting likes. Let's make sure we continue posting there. You could have like, just general talk. You can have the separate aspects. You can have an autonomous channel, right? Say with all the video updates of how the autonomous is going. You can have a documentation channel specifically for posting, at least 3 pictures a day. And if you have those at least 3 pictures a day, you can prove that work got done that day, right? You can, in your notebook, say, oh, I forgot 2 weeks ago, what were we doing? Let me go back to the documentation channel. Oh, it says we only have these 3 pictures. Oh, and it looks like we didn't get too much done that day. Okay, that's fine. It's going to be a brief entry in the notebook this time, and that's fine. That's what you're doing. So that's our kind of quick on Slack, similar to Discord. We've got our Git projects. So we've got GitLab in this instance. So GitLab, GitHub, whatever you want to use, it's whatever, it's whatever your preference is. So for example, let's say that I was working on some sort of web interface, and now I can go back to let's go to my testing learning. I can see all the different commits that I've done, right? So I can say, oh, so-and-so added a local button for use in the Ultra 96. Okay, that's useful. Now I know, in that day, what did we get done? I can go in my notebook. I can say, okay, on, December 13th, what got done in the code? Oh, according to this, they added another button. They added an autonomous. They added the ability to score, whatever it might be. It's super useful to use, and it's definitely used all across our industries. So, make sure you at least try to kind of get some semblance of that. And, it's super useful because I can just say, oh, well, I totally messed up my code. Let me go back and check what the code used to look like. Oh, okay, the code used to look like this, and we got rid of these lines, and we got rid of all this lines here. We added a function, we got rid of that. All these different things that you did, you can kind of track and you can work on. And let's say that I lose the code. Let's say that, so-and-so accidentally messes up the code or whatever happens, you can always go back to a repository, right? You should never have to rebuild the wheel for doing the same work. If you know that 2 years ago, you made an autonomous that was multi-processed, you made an autonomous that really followed lines well, you made an autonomous that correctly uses the gyro, or, you made your own telemetry, whatever it might be, telemetry, odometry, whatever it might be, right? You want to keep track of that. You don't want to lose it, because, what's going to happen is next year you're going to say, oh, well, how did that go again? I don't really remember. Or what if somebody on your team who's new to robotics needs to see an example, right? You can quickly provide them an example of, oh, well, here's some code that somebody wrote, a year ago. You might be able to look through it and get some ideas as to how you might want to approach this. It helps build not only your own skills in terms of using these professional tools, it also helps build your organization, right? So you don't have so much kind of information lost every year. Because that's the issue people face, right? Is whatever organization, club, school, private team, whatever it might be, might have new students coming in. And those new students are new students. They might not have experienced robotics before. But if you provide them the proper resources, they can definitely, beat the learning curve and get a lot of example or a lot of advice, a lot of good help. So there's that. And we just got like generally GitHub, so another implementation of just a Git product, revision, version control and such. So same thing, I can open up a code, I can see, oh, well, the hot package was disabled, build was successful. Okay, that's the last successful build of our make file. Whatever it might be, I can kind of push it there. I can go to my source, yada, yada, yada. I can see, oh, the autonomous, oh, okay, or operator control is a work in progress. It's not done yet. I might have to go to a different commit or go back and check later, right? So these are all different tools that are super useful for you to leverage, because one, we're going to be working from home. You're going to have a lot more time to think about these type of things, and they're really good for you as a professional who's trying to develop, right? So super useful, definitely would recommend. All right, this unique season. So let's talk about it, right? As we all know, the whole world has been impacted by coronavirus, COVID-19, SARS-CoV-2, whatever you want to say. It's been impacted. So now what we have to do is we can't just kind of be like, well, darn, there goes my season. We have to be active in the decisions we make, and we have to make sure that we maintain control of our season, right? We can't just kind of like let things fall however they want to fall. So, we have to understand that this season will be uniquely different for pretty much every organization in existence, right? Everyone's going to have to like sit there and be like, oh, well, let's see, how does this affect our ability to prototype? How does this affect our ability to write code? How does it affect our ability to make designs? How do we allocate our time? What do we do? Understand that, if there are issues that you're facing, there are issues that other people are facing. And so this season might be different in the sense that, the early season might be later, or you might have less time to do driver practice. You might have less time to, you might be able to go to less competitions. These are things that you should kind of consider, and maybe sit there for like 5 minutes and think about, what's going to be different because of the situation we're in this year than last year, and how can I do something to change that or take advantage of that. So, wait, that's not what I meant to do. All right, we're gonna pretend that did not happen. You see, we're just gonna run it back. It's like nothing happened. There's another part of me clicking the wrong button. Yeah, awesome. There we go. All right. Yeah, so it will be different for pretty much every organization. So, make sure you establish the workflow for remote working. Make sure that, because most of the time people, when they're doing work at the robotics clubs or the robotics organizations, they come in and they meet up and they just start doing work together. We can't really do that type of a close quarters meeting scenario, right? This year, we have to be socially isolated. So maybe we should establish how we're going to get work done remotely. We should spend some time. We should think about, well, what can we really do when we're not together? Maybe we can do some more CAD. Maybe we can do some more strategy. We can spend a little bit more time, running simulations or running like hypothetical matches in our head. Like these are active things that we can do to take advantage of the extra time we have that we might not have had in previous seasons. Additionally, the same amount of work still needs to get done. We need to find the correct way to do it. So definitely, sit down and say, well, now maybe we need to have meetings every week. Maybe we need to have meetings every other week. You'll need to keep track of your time more. This season is different because, previously your time is just your time. You just show up, you do building. This time it matters what you do with what piece of your time, right? Some things you can't do alone, like driver practice. You can't really do that by yourself, right? I mean, sure, you can have a one-person driver, but without a robot, what can you really do? So maybe you want to say, okay, any opportunity we get to meet together, we want to push towards driver practice, or we want to push towards autonomous practice, because these are things I cannot do on my own. But CADing, I can do on my own. Practicing the strategy, I can do on my own, and maybe have a virtual meeting for. So there's some things you need to keep track of as to what you do, right? Be critical of your time usage when you do meet. When you do get like meeting time, be very critical as to what you're doing with that time. I can't count the number of times where I'd be in a meeting and, we hit maybe that 45-minute mark of that meeting, and then people just start to get really sidetracked, right? They go on off in tangents. They start going, oh, here's a cool meme I found. Here's a cool joke. Here's a cool something. But, that's cool to do, but that's not the purpose of the meeting. You want to save the time you're using and be very, meticulous in, hey, well, sure, that's cool. Let's do that after this. But right now we only have 5 minutes left, and we definitely need to talk about, how we're going to take advantage of autonomous this year. So, these are cool things you have to kind of take advantage of. Please always have an agenda. That goes into being critical of your time usage. Any meeting I've been in that doesn't have an agenda, I've found that it normally takes significantly longer than it needs to be, right? Like, for example, the first thing that always ends up happening is we all just kind of stare at the camera and we go, hey, what's up? And we just kind of stare there and we go, I guess we'll begin, right? And we don't know what to begin with. But if we had an agenda, we would know that, hey, the first thing I'm going to do is I'm going to talk about the work from last week. And then, with that work from last week, I'm going to go around, I'm going to share what we got done. And then we're going to talk about, the difficulties we faced. And we're going to talk about, how much extra time do I need because of these difficulties or unexpected predicaments. Okay, now we've gotten that taken care of. Let's talk about what are our plans for next week, or what are our projections, right? These are all important things that you need to discuss. And it's very good to kind of spend 5 minutes making that agenda beforehand, because after you do that, you can then take that agenda and the notes you had from the points on that agenda and put it into your documentation, right? You've quickly just broken down every important thing you're going to do. You got rid of all the extra stuff. And then you said, okay, well, we talked about the work we got done last week. And, Julie says that she needs more time with the autonomous because, it's really hard to tune the gyro sensor without whatever it might be. Okay, well, now I can, in my notebook, I can say, okay, so she got this much done on the autonomous, and the difficulty she faced was this, and she faced it because of this, and she might need a little bit more time. That's our projected is 1 more week. So like you're doing this documentation, and it's just because you added an agenda, right? You're making your notebook so much stronger. Don't use meeting time to work. So that's big, in your meeting time, because we're in this unique point where we can't just like, hop on a call and do work together. It's not like previous years where you just show up to your robotics practice and at practice, you just do work, right? And this time you can do work without the meeting. Some things you do need to meet with, and sure, you can do that work during the meeting, but you don't need to be like, all right, let me turn my camera on. Let me like go to the meeting and let me just start turning screws. The rest of your team doesn't need to see you turning screws right now. They need to be getting their own work done, right? So sure, you can have a meeting where, if you prefer, you can totally do that, where you have a meeting and say, okay, this is going to be a 2-hour meeting where we just kind of work together, just so you cannot be alone when you work. And that's fine. You can do that. But if you're having meetings where you share the progress that you got to, it might not be the same meeting that you want to say be doing a lot of that work, right? Because that defeats the purpose of the meeting. The meeting is so you can sync up yourself with what other people are doing, not just you can continue progressing, right? The progression you kind of do on your own. The meeting is so you say, hey, so-and-so, this is what I got done. What did you get done? What did you get done? You kind of check with other people as to where they are, so everyone's on the same page. It's like a synchronization tool, right? So, look at your season and please try and predict when the early season is. So an example of this I can think of is, for example, I'm in Virginia. So in Virginia, I could say, okay, well, all our competitions are pretty much held at public schools or, you know, those public government type areas. So I need to figure out when they're going to open. Okay, well, let's see. I don't think the governor said anything until like June, July. Oh, well, you know, schools are already planning to be online next semester. So maybe none of the public schools are going to be open next semester. Maybe they're not going to be open until after winter break. So our early season of competition might not be until January. Now that I've made that prediction, I can plan. Okay, well, if January is when I expect there to be, you know, the latest time that we can actually begin competing, maybe I want to make sure that I have a solid design in mind by September. And if by September I have a solid design in mind, then by October I can have a lot of the building done, right? Because I've already done a lot of the CADing and design by September. And okay, by October now I have that. Maybe by November I want to be 2 iterations in. I want to have improved the robot at least twice all the way around. So every aspect, whether it be the drive, the intake, the lift, the scoring mechanism, I want to have gone through 2 versions of those. So they're now twice as good, or 4 times as good, I guess, if it gets doubled every time, as what it was when it began, right? And so now I've like kind of outlined my prediction for the season, because, you know, taking these active steps is what prevents procrastination. You know, I've definitely seen it where people go, oh, you know, it'll happen when it happens, and, you know, we can get to that. But every time you say we can get to that, you kind of put it off to a little bit later, a little later, a little later, until it doesn't end up happening. You know, if you wanna make something happen, you have to be active and say, hey, let's do it now. Let's get this work done. Let's not put this off until later, because later is always going to be later. It's never going to come. So leverage your extra preseason time by researching. So now that you have this extra like preseason where you're not in school, you're not, you know, you're not taking active classes in person, you might be able to, you know, leverage that extra time. Maybe do some research. Maybe look at, you know, for example, what type of machines already exist that do a similar type of job. You know, if we're like this year's game, right? Change up is picking up balls and putting them in goals. Okay. What previous game can I look at that had something similar? What like industry standard things can I look at that already do that? You know, are there already existing engineering solutions for this problem? If so, how can I make a VEX version of that solution, or a better version of that solution? You know, do some sort of research, because you're not going to have this type of time next season, right? Like typically when it comes to September and you start meeting with your team, you guys just hop into it. You guys just start building. You guys just get to it. You know, you start putting parts together and start prototyping. But now you don't have that opportunity because you can't meet together as much. So you definitely need to take advantage of that extra time you have now for doing that meticulous thinking and planning. Identify when you need to be in what stage of the design process. So that's important. You know, make sure you're kind of keeping track with when you need to be where, because, you know, that helps you understand how well you're doing so far, especially with this season where, you know, things probably won't play out as they normally do. You know, you probably won't be able to go to a competition until January. So maybe you need to identify that January is your time you need to have a prototype robot done by, instead of maybe October when you normally do your first competition. Or maybe you realize that, oh, you know, well, January to March, if your state championship is in March or something, is only so many every months. January, February, March, there's only 3 months. That's not, or 2 months really, because all of January, all of February, and then March. So maybe we won't get enough time to prep for states. So we really need to make sure that our states robot is ready by that first competition in January, or whatever it might be, right? These are active decisions you can make. I personally would say, if I know my state championship is in March, and I know, or I predict that, you know, my first competition is not going to be until January, that means that I'm going to say, okay, instead of going to 5 competitions like we normally do, maybe I'll go to 3. And, you know, maybe during those competitions, I'll make sure that every time our robot is kind of prepping with states in mind, and that, you know, by middle of February, we have our states robot done, which means we need to have our first prototype version done in September, even though we're not having a competition, right? I need to have a lot of CAD done. So those are like things you can think of, right? You know, remember, you don't need VEX parts to prototype well. So, you know, a lot of people, and I'm a visual person as well. Sometimes are like tactile. Sometimes I really just need to have like, you know, a C channel in hand and a wheel to kind of like get an idea of, oh, well, on this hole it lines up like this, on that hole it lines up like that. And it does help. But, you know, you can kind of overcome that through CAD. So like, for example, this season, my sleep schedule totally thrown off, totally like screwed up. You know, I'm up till maybe about 6 a.m. every day. And that's because that's just what my sleep schedule is. But what I've done is I've started taking advantage of that. So every day from about like, I think, what is it, about 2 a.m. to 4 a.m., right? About 2 a.m. to 4 a.m. every day, I CAD for 2 hours, just so I can get some work done. And I know I'm going to be up. I know that, this shift to online learning has done whatever to my sleep schedule. I'm going to take advantage of that. I'm taking those 2 hours a day where no one's going to be bothering me. There are no distractions. I can just do whatever to CAD. And, that'll help me achieve my goal of having an early season prototype done by September. So there's that. And, recognize you might not be able to go to many tournaments. This season, like I said, is different in the sense that all our seasons are going to begin later for sure. I mean, no state is going to be okay with letting us go back to competitions immediately, right? We have to recognize that some countries, even like, what is it, some of the East Asian countries, like if we're thinking Singapore, if we're thinking the China area, have a lot of their competitions during our summertime, right? So we might have to think, okay, well, normally we rely on looking at those tournaments to get ideas. Maybe we won't be able to do that this year. Maybe, maybe we'll have to wait a little longer to see what people come up with or something. Try and make a plan, try and be active about it, right? Because being proactive is how you maintain control. You definitely want to avoid being reactive in the sense, because then you're just kind of like, making things up on the spur of the moment, however they come. So there's that. My recommendations for this season: start meeting virtually to get everyone on the same page and get the ball rolling, right? You can't just keep pushing it for next time. Okay, Shelby. So this year will states and worlds most likely be late. So I mean, I'm not one to speak for the REC or VEX Robotics because I'm not them, but it would be their decision as to how they would want to move the World Championship to be forward. And with their decision, it probably affects your state's decision, right? Because your state championship normally tries to give you a month, maybe two, to prep for Worlds. So if they decide to keep states at the same time, or if they decide to keep Worlds at the same time, then hey, your state might sit in line and keep their state championship at the same time. Maybe they'll move it back a little later, but then they have to ask themselves, how does that affect other people? How does it affect people who are going to AP exams? How does it affect people who are taking final exams? These are all considerations they have to make. So, maybe it'll end up at the same time. I feel like it might, just because, if it affects everybody this season, then everyone's going to be kind of negatively affected the same way. No one would have kind of an unfair advantage in that sense. So it's possible that, your state championship and your world championship stay to be at roughly the same time. It's possible. I mean, again, I can't speak for like the state of Minnesota. I can't speak for the state of Virginia. I can't even who knows what they might do, but definitely try and be proactive and maybe make a plan A, plan B. Plan A, if they keep states at the same time, plan B if they push it later. Yeah. So, make sure we start meeting virtually to get the ball rolling, because that's how you kind of cut that procrastination immediately, because that gives you immediate deliverables, right? In between your first few meetings, do some CAD or theoretical matches. So let's say we're in my meeting, meeting number 3, and we've talked about the game. We've kind of broken the ice there with that. Let's start doing some CADs and theoretical matches. We have extra time. We physically don't have parts. We might as well be doing work in parallel, right? We might as well pull out the CAD, get a design done. We might as well do some theoretical matches. We might as well figure out, how do we think this game is going to play? Because we know that if the early season is in January, like we're predicting, then, okay, I'm going to have a significantly smaller amount of time there to do a lot of iterating, right? So I need to make sure that when I hit the mark, I hit it well on January. So I need to do a lot more theoretical matches. I need to do a lot more CAD. Personally, I think I've been able to have the majority of a robot done across just a few hours of work, spread across a bunch of nights. So it's definitely doable. Every meeting, do a stand up and share progress and then take opinions. So this is kind of a standard process that people use. Is every meeting that they have, whether it be virtual or in person, they try to do a stand up and share the progress with what they've done. So for example, we did our Trello board and I was assigned to work on the autonomous, Nate was assigned to work on the code, right? So what will happen is we'll go to our Zoom meeting, our WebEx, collab, whatever it might be meeting, and we'll say, okay, so Afnan, what did you get done? And I kind of stand up and say, okay, well, with the whatever I was working on, maybe the design, the notebook, the autonomous, I was able to get X, Y, and Z done. And, I was not able to get D done because that was a little difficult. I might need an extra 2 days to do that. Okay, cool. Now it's your turn. Now it's someone else's turn. Now it's Nate's turn. Now it's someone else's turn, right? We're taking turns sharing the progress we've done so that everybody knows the updates from every single part of this design process, right? So everyone's on the same page now. Okay, so now what we need to do is, while we're doing this progress, we're taking in opinions as well. We're taking in people saying, okay, so we've shared all our feedback. Does anyone have any particular opinions about what we've said? Okay, when someone goes, oh, well, I think that it's really good that our code is on track, but I would recommend that you try doing X, Y, and Z as well, because we think, it'll take a little bit of extra time to do that. So maybe start doing that. An example might be, I shared that I shared that I don't feel like I have anything to do on the autonomous because we have no robot to code. And Nate goes, Afnan, what are you talking about? You can at least write the code to have like a rough 4-motor base, right? And you can write a rough autonomous to make it go forward, or you can outline the autonomous you want. Or Afnan, you've never used a copy, you've never used pros, you've never used VEX code. Maybe you can try and download those and try and get used to them. So these are ways we can be constructive and we can synchronize the work we're doing, but also not have to do that work during that meeting, right? So after the meeting, I'd log off and go, okay, let's figure out what this VEX code is all about, man. Just do that. Try and spend no more than 60 minutes in a meeting, because remember, the meeting is for the point of synchronization. It's not for the point of doing work during that meeting. So you should synchronize, and it shouldn't be very long, because at some point, there's a limit to what you can say. And once you hit that like 60-minute mark, and 60 minutes is really a long time in meetings, like you start to get the sidetracked, you start to get people who are like, oh, I'm going to get a snack real quick. It's okay to eat, but like, you don't want to get sidetracked, because that's going to, one, elongate your meeting, and two, get less work done. So, it's super easy, 15 minutes, 30 minutes, just say, hey, this is what we got done. This is what I think we need to get done next week. Boom. At the end of every meeting, assign deliverables for next meeting, right? So this is a great way of making sure that every meeting, when you come up, people have something to share about their deliverables, is by formally assigning them and saying, hey, Afnan, next meeting, you need to have a good autonomous theoretically together. So, that's a great way of doing that. Use tools like Trello and manage assigned tasks, right? You have the extra time, you might as well take advantage of it. Use the tools you've got to leverage leverage the things you can. I could say, make my documentation so much better if I just use Trello. I can make sure that everybody knows what their tasks are for next week by, by making a ticket on Trello, making a card as they call it, and then, assigning them the card, giving them a checklist of things to do, and giving them a due date. Everyone's always clear on what's being done and what's due and who's doing what. If you can get parts, decide how you'll allot them, right? So it's possible that you might be able to get parts from your organization, whether it be a school or private team. Figure out how you're going to allot them, because it might not make sense to say, okay, well, we've got 15 C channels and 3 people on the team. Here, everyone can have 5 C channels. What are you going to get done in 5 C channels? It might not make sense to just give everybody the parts, right? Maybe you want to say that, hey, we're going to give, let's say Julia, we're going to give her all the C channels because she's really good at building, and she normally leads our build process. So what we can do is we can assign all the building to her, and she'll do all the building, even if it's like a prototype idea I had. So during our meeting, I'd say, hey, Julia, I had a great idea for an intake. What about this and this and this? And I'd show her a drawing, and then maybe her next deliverable could be for her to make that intake, because we have all the parts in one place. That doesn't require people to go across however far and not be socially isolated. So that might be a way you want to approach it. Maybe you want to say, okay, we're gonna have these 2 people. You can get half the parts. You can get half the parts. And this person specifically works on drivetrains. This person specifically works on intakes, and break it up like that. Figure out how you're gonna allot the parts, because at some point in time you're gonna get parts, whether that be because the school let you go back in and retrieve some, or because you went back to school. Figure out how you're going to allot that. Focus more on your documentation. You already know that everybody this season is going to have less driver practice, or it's going to be a little harder to get autonomous done. But the best way you can take advantage of the time is by just shoving it into your documentation, because you might not have those parts and pieces, right? You shouldn't just say, hey, well, my school's not letting me get C channels. Darn, I guess we'll just lose the season. You have to realize that there are only having a great robot is cool because it lets you win the tournament champion. It lets you win, robot skills, but it doesn't give you excellence all the time. It doesn't give you design all the time, right? Excellence is a combination. It's got to be a great robot and a great documentation process and a great interview and all that, right? Design doesn't even care about your robot. Your design's about the process, right? You having a good robot's helpful, but if you've got a great documentation system, then that notebook is going to be good, right? So strictly speaking, you have a lot more award opportunities in the documentation. So it might be worth it to spend this season saying, hey, maybe we're going to focus a little bit more heavily on this so we can have a higher chance of getting awards that qualifies for states and worlds. Learn CAD if you don't already know it. We have extra time. Please take advantage of it. Hop in a CAD seminar. Maybe Nate can show you some cool 3D printing stuff too. Like, there's so much in the world of CAD that's super useful for VEX. Grab a part library. If you don't have one, I'll give you my part library. Like, I have one, right? Please learn it. It's super useful for you guys and prevents you from just like sitting there and saying, here is my drawing. It's labeled. It's like, it prevents you from the awkward situation of either drawing something and then having somebody else build it because they have all the parts and they weren't able to build it correctly, or they weren't able to understand what you're trying to say. It also helps you provide like exact spacing and stuff. Like in your drawing, maybe somehow magically or the wheel doesn't hit the intake, but when you do an exact CAD, the wheel always hits the intake. What CAD software is my CAD library designed for? Cool, great question. My CAD library that I personally have is for Autodesk Inventor Pro or Autodesk Inventor. There's a separate library I also have that's actually made by Oscar, who I think is here today, who that is made for Fusion. So we pretty much have most of our bases covered there. So maybe send me an email or message or something, and then we can link you that so you guys can take advantage of that, right? I think we also have Nate. There's like a CAD STEMinar, right? You're muted.
Sorry about that. Yes, there is a CAD STEMinar, but I don't remember it off the top of my head what day it is, but it's on the Fab Lab website.
Yeah,
the list.
Yeah. So I think it uses Fusion as well. So we've got all these things out here for. People are, Oscar, go ahead and post that link for the Fusion in the chat, please. And if someone still needs it, before that, then or after this, then please send us an email. Just reply to the email, and we can definitely provide you that library. And once you go back to the meeting, what you're going to use most of your time for, know that you're going to use most of your time for driver practice, maybe autonomous testing, because those are things you can't do on your own without parts, right? So maybe once we go back to school in January or whenever it might be, say, hey, we should spend those first 2 weeks, making sure that we get this design built the way we said, and then spending the next 2 weeks, getting our autonomous done and driver practice done, because it's super helpful. So that's my recommendation. We're going to go and hop into breaking down change up just a little bit. It's not going to be super in detail, but we're definitely going to go through it. And if we have time, we're going to break down toss up as well. Maybe we can just do Q&A. We'll talk about it, right? So I hope you guys are ready. Let's change the share. Yes. I'll make sure to provide. There we go. Share. All right. So, hello. There we go. All right. Let's look at our game. Right. It's breakdown time.
Welcome to the world's greatest 2 minutes in robotics. The 2020-2021 game, VEX Robotics Competition, Change Up.
Change Up is played on a 12-foot by 12-foot field by 2 alliances, 1 red and 1 blue, made up of 2 teams each.
The object of the game is to get more points than the other alliance by scoring balls in goals and by connecting rows.
The VRC change-up field contains 32 balls, 16 red and 16 blue. Each robot starts the match with one of their corresponding balls as a preload. In addition, there are 9 goals located around the field where balls can be scored.
Balls are 6.3 inches in diameter and are worth 1 point for the corresponding alliance color when scored in a goal.
An alliance can take ownership of a goal by having the top scored ball in the goal. If an alliance has 3 owned goals in a row, they will receive a bonus of 6 points for connecting the row. But watch out!
During the driver control period, robots can remove balls from any goal at any time. This means that even if a goal looks full, an opponent could descore one of your balls, open a spot for a ball of their own, and interrupt a connected row. No scored balls or connected rows are safe. Each match begins with a 15-second autonomous period where robots score on their side of the field without help from their drivers. The alliance that scores more points in the autonomous period is awarded with a 6-point bonus added to the final score at the end of the match. This year, each alliance also has the opportunity to earn an additional win point in the autonomous period by completing their home row. The home row is the row of goals closest to their own alliance station.
The 1 minute, 45-second driver control period begins once the autonomous bonus winner has been determined. At the end of the driver control period, after all objects and robots have come to rest, the match will be scored to determine the winning alliance. Remember, VRC games are not scored until the driver control period has ended.
Official rules and game information for VEX Robotics competition Change-Up can be found at roboticseducation.org.
Okay, that was pretty cool. So right off the bat, guys, what are we thinking? Feel free to use the mic in this case, or feel free to hop in the chat and let us know. But I'm pretty interested with this game. I don't know. What are some cool things we noticed? And here's what I can do. I can go ahead and make a new share. I can share the screen. Yeah. So you should be able to see the screen. So like for change up, autonomous win point bonus. I couldn't agree more, right? That's huge, right? So it looks very similar to toss up, and we're getting win points in autonomous, right? So we already know that autonomous super huge. So maybe we can make a note, auto, I'm going to spend a lot of time on there because I can get a win point. I could literally lose the match and still get a win point off that. And then, 6-point autonomous bonus when everything else is worth 1 point. That's a lot of points. Like the balls are almost useless at that point, except for playing the tic-tac-toe game. They're not very many game objects. Yeah, and that's a great point. So we're looking at a game with not a lot of game objects. Maybe consider doing some sort of horde, rows of 3. So maybe like some sort of, maybe think about having a holding capacity of 3, something around there. Home row is super important because you get the auto points off there. Middle tower is hard to play with. Yeah, so there are 4 poles. Think about that. In the middle tower, on the bottom, there are 4 pegs. You actually have to physically push something out. It doesn't just fall out. Let's see. Yeah, so ranking can be more accurate, as a good team should have get the home row and get more win points. So we might see some sort of higher amount of win points, more than just a standard 10 if you play 5 matches. Control the middle tower. Yeah, so the middle tower is part of how many rows? 1, 2, 3, 4. That one tower there alone is part of 4. And speed games, so that's one thing to consider, is it might just be all about how quickly you can put it up, how quickly you can put stuff up and put it down, right? So definitely consider going in, looking at making your designs really quick in that sense. What else? What do you guys think? I mean, we're gonna try and avoid getting too far into it, just because there's a separate summer camp for that, and we're gonna have those links available shortly. But we are gonna have some brief discussion and such. Rows are worth more points than the balls themselves. Yep, that's big. Talking about cycle time. So that's another important thing to think about, is how much time does it take you to go from ball on the ground to ball on the goal, and how can you minimize that? Yes, is that talking about to my teammates? It is a speed game. Possession limit. Yeah, so that's a question. Is there a ball possession limit? How many can you hold at once? That might be something to consider, especially because they're pretty big balls, right? They're 7 inches, and your robot's 18 inches. So 2 of them is almost your entire robot. So maybe you have to do some consideration as to how many you want to hold at a time. Middle tower doesn't have a backboard, so you can't just shoot threes or whatever. You gotta kind of get a little closer to that middle tower. Let's see. The score and descore at the same time, pretty important. Yeah, because if the thing is full and you want to put something on top, you got to take something out the bottom too. Definitely more ways to get points. Yep. 6 inches, excuse me. Yes. So it's 6.13, I think. Yeah. For the ball. Ball is roughly 1/3 the size requirement. Yeah, that's kind of important there. If the ball is 1/3 the size requirement, and you got metal and you got intakes and you got stuff, you're gonna end up taking up a lot of space just to hold those balls. All of your color and 3 of the other team. Yeah, so the ball possession limit, be wary of that. Try and figure out, you can hold as many as you can of yours, but only 3 of your opponents. So keep that in mind when you're thinking about, hoarding, Evil Santa, any sort of thing you're thinking of. But you can't really double unless you get 3 in a row. Yeah, so you do need 3 in a row to get that like multiplication of points. So maybe it'd be more advantageous to have a coach, actively looking for that. And Charlie brings this up. The task is super simple. Like that's really interesting, right? This year's game is not dynamic. Like it's not complex in what you have to do, right? You just put a ball in the thing. You're literally just playing tic-tac-toe with balls. It's not very difficult, but the points come from being intelligent in the way you do the simple task, right? And how you do it. So, strategy a ton seems more important than having a slick design. And I couldn't agree more, right? I'm sure that, there will be some slick features of designs that are important, but there is very much, very much a simple task that you're doing. So you don't necessarily need to over-engineer that simple task. Unlimited expansion. Hey, maybe someone's got a wall bot they're going to pull out. Who knows? I'd look forward to seeing something like that. I think the 18 by 18, of course, is the starting, but you can expand however you want. So you ready for that? It's Connect 3. Yeah, it's not Connect 4. It's Connect 3. Seems more design. Yeah, so it seems, programming skills being big this year. There's a lot of things to this game, and it looks like strategy is going to be key of those. And I really wish I could talk more about that, but I know I have to hold off until the summer camp to talk about it. I'm really excited. I hope you guys are too. But we're definitely we're gonna break this game in that strategy talk. So, strategy for Turning Point. There was some strategy for Turning Point. It was pretty important. Having a good robot and stuff like that. But all right, so I think we've definitely talked about this game for a little bit. So I'm gonna go ahead and pause. I'm gonna recommend you all, if you want to continue talking, we definitely do this in our summer camp that we're gonna have. It's gonna be super exciting. But now we're gonna look at a game who might be a little bit similar. We're doing toss-up.
Introducing the 2013-2014 VEX Robotics competition game, VEX Toss-Up. VEX Toss-Up is played on a 12-foot by 12-foot field by 2 alliances, red and blue, each made up of 2 teams. There are 8 large balls, 4 red and 4 blue, available in the game. These are the largest scoring objects ever used as part of the VEX Robotics competition. There are a total of 20 buckyballs, 10 red and 10 blue available in the game, 4 of which must be used as robot preloads. The object of the game is to attain a higher score than the opposing alliance by scoring colored buckyballs and large balls into the middle zone and goal zone. There are also 2 vertical cylindrical goals on one end of the field. Teams can score points by stashing their colored buckyballs into the goals, or by stashing their large balls on the goals. Teams will also receive points if they are hanging from their colored bar at the end of the match. Robots are said to be low-hanging if they are off the ground, but below the height of the field perimeter wall. They are high-hanging if they are above the height of the field walls. Robots that are holding their colored ball will get additional points while low-hanging or high-hanging. The hanging zone and middle zone are separated by a 2-inch high bump. Teams will need to design their robots carefully to make sure they can get over this obstacle. The middle zone and goal zone are separated by a 12-inch high barrier. Some teams will want to design their robots so they can get under this obstacle. Let's take a look at some typical match play. Each match starts with a 15-second autonomous period. Robots move around the field without any drivers. The alliance that scores more points during the autonomous period will be awarded with 10 bonus points at the end of the match. After this, drivers will take control of their robots and have 1 minute and 45 seconds to score as many points as they can. This year, we expect to see scoring objects tossed back and forth throughout the match. VEX Toss-Up is a back and forth game. Objects that are scored may not stay scored for long. Robots may try to move their opponent's objects towards the hanging zone to reduce their score. Robots can hang off the hanging bar for big points at the end of the match. If they do it with a large ball, they get even more points. Let's see how matches are scored. Buckyballs and large balls scored in the middle zone are worth 1 point each. Buckyballs scored in the goal zone are worth 2 points each. Large balls scored in the goal zone are worth 5 points each. Buckyballs stashed in a goal are worth 5 points each. Large balls stashed on a goal are worth 10 points each. A robot that is low-hanging is worth 5 points. A robot that is high-hanging is worth 10 points. Hanging with the ball is worth 10 bonus points. For more information on VEX Toss-Up, see the official rules at robotevents.com or vexrobotics.com. And be sure to visit the
All right,
VEX...
guys, so what are we thinking here? This is it's pretty interesting, right? So we're looking at, hanging doesn't really seem worth it. And that's an interesting thing, and I'm glad you brought that up, right? So, and let's kind of let's do this, right? So I'm gonna scroll down, gonna go toss up. If we're looking at our points, right? Hanging was like what, 5 to 10 points for a hang, with a bonus 10 for the ball, right? And so that's like interesting, because if you put a ball on top of that stash, then you got the 10 points anyway. So, a ball with it is plus 10. But if you have 2 balls on those stashes, you pretty much just overcame the hanging with the ball, right? So we may want to question if it's worth doing the hanging. Oscar mentions there's an artificial height limit, and that's really important, right? Although you have 18 inches you can build up to, the like barrier in between, so barrier, that's like 12 inches tall. You might want to build a robot that's only 11 inches tall, so you can get under and then be able to play on all sides of the field, so you're not just kind of stuck, right? Additionally, if you look at just the field alone, we've got that kind of 2-inch bar in between. So we need to be cognizant of that bar being there, and maybe we want to make sure we don't bottom out on that bar. So whatever our wheel design is needs to take into the fact that, when I'm going over, my robot shouldn't, 1, fall because its weight is wherever it might be, and then 2, we have to make sure we don't just get stuck and we're not like a beached whale kind of stuck there, right? Big wheels, maybe you want to have maybe this year you want to justify using 4-inch wheels instead of like the 3.75s, or maybe even 5-inch wheels, just to make sure you get over. Elevated chassis and big wheels, yeah. So make sure that the C channels don't scrape against that. You need like 2 inches of clearance when you're going over. So that's another big thing. So something I thought was interesting was the fact that if we look at the balls, right? They said there were 10 buckyballs per color, and 4 of them are preloads, right? So that means every robot starts with 1 preload, but that means there are also only 6 of your buckyballs on the field. So, maybe, and look, if you look at the stash, it looks like it holds about 3 or 4 buckyballs in there. So, and once it's in that stash, you can't really take it out, right? So you definitely want to think about rushing to get something in that stash, because once it's in there, those are guaranteed points. Those huge beach balls will go back and forth, but once those buckyballs are in, no one's going to de-score them, right? So let's see. The bigger balls are almost as large. Yeah, bigger balls are almost as large as your robot. That's like going to be really hard to pick up. So you definitely need some semblance of an expanding intake, right? It's pretty whack there. So maybe if you have 2 stashes, right? That's supposed to be. And we're just gonna stash 2 stashes. Each hold 5. That equals a total of like 10 buckyballs you can put in the stash. That means like roughly you can either put all of your buckyballs or your opponent can put all of their buckyballs. So you definitely want to make sure that you get all your buckyballs in there, right? Because that's 5 points. That's the equivalent of having one of those like big balls in the far goal zone, in the high goal zone, right? So if you can rush to get all your buckyballs in that stash, we're looking at a total of 50 points you could get off just those buckyballs. If you stash a large ball, you have to get rid of it if you want to stash more. Yeah, so that's a good point, Charlie. So maybe you want to stash that tall, like that biggest ball, you want to do that last, right? Because once you put that on top, you're going to take it off to put more buckyballs on. So your early game strategy should be, hey, I'm going to push all the buckyballs I can in early game so that I can spend the late game focusing on those beach balls. And so that's a good strategy. That's a strategy we definitely saw at a lot of high tier play. Also, just the fact that you can throw those beach balls across might mean it doesn't take too much effort to move ball from point A to point B, right? So we can expect that, if there are 10 seconds left in the match, there's still some possibility for the balls to go back and forth. Additionally, a strategy that you might think about is, well, instead of maybe throwing that beach ball across the field, maybe you could just pick it up so it's not, touching the goal zone. So instead of being 5 points on the ground, you just pick it up and it's worth 0 points. So that's like a kind of a strategy you could consider there. Another thing is if everybody starts with a buckyball, and if you look at the like starting configuration, where is it? Yeah, so every robot's got to start on a colored tile, right? So what if you took your preload and you gave it to your alliance partner during autonomous, just so they could put 2 of those in the stash, right? Because what that does is if you start on the backside of the barrier, it's going to be kind of hard for you to score in the same stash as your alliance partner, right? So maybe if you're in the back zone, you want to focus on getting those buckyballs that are along the back into the far zone so that your alliance partner can then take them from there and then score them in the stash, right? And then while they're waiting for you, maybe they can play some sort of defense to keep your opponents from scoring in their stashes. That might be like a good strategy to have so that you can make sure that as soon as that robot is done pushing their color buckyballs into the far zone, they go back and then, they help score in that far zone, just so you can lock down the 2 towers, or the 2 stashes. After that, it looks like it all comes down to the beach ball play. They do start on top of that barrier, so it's going to be kind of difficult to get. You probably need a robot to put a ball on a different robot when it's hanging. Yeah, so you might need to do that. You might need to have a robot able to, assist your robot while it's putting a ball up. If you don't, then, you're going to have some mechanism that lets you hang without dropping that beach ball. And so what I'm going to do now is, these are all great ideas. We're going to watch some gameplay because we're running short on time. We might not be able to break our rules down, but I definitely want to show you a few review videos that defined a lot of the strategies you saw and prove that the ideas we've had are going to be like, really good, really kind of competitive ideas. Larger balls can roll. Maybe you can just push them around if you're short on time. Yeah, large balls roll. Maybe just push them around. So this is going to be from what, let's see. I think this is Tiger Yang's review. Yeah, 9090C. And so, going through it, it's a review video, so it's got a lot of fluff. But so one thing that we should notice is, okay, so he's got a scissor lift. He's got a 3-ball capacity. He can immediately do it. On the back, you should notice that there's like this big like T-shaped thing. That thing is specifically designed, right, to help him put that ball up top and also help knock balls as he passively drives under. So he no longer has to lift his robot to knock those beach balls off that barrier. All right, we've got a hanging mechanism here. So you'll notice that, he didn't need his partner to help him because the backside was used for that. So, all right, looking at ball, maybe that's his autonomous, goes up, goes for a score, buckyball first, and then ball on top. So maybe if your autonomous can do that, you might want to do it, right? Because it's worth those 10 extra points. All right, goes under, and see that little passive like knock thing just knocks off a ball on top just because he drove under it. So he doesn't have to actively go up there. So it might be beneficial to have a similar mechanism, right? Because that's less work you have to do. He just pushes it over and it's easy mode. That's 5 free points just by driving in a straight line. So, okay, so he's going up, he's going to score. So there's this robot, right? And now we can kind of compare that to what other thing we see, which is Pastoral Invasion, which is like another one of the like popular robots, from that season. So they've obviously got a launching mechanism. So like the video showed, we can expect them to be doing a lot of launching, last second, getting a lot of their points out the way. What you'll also notice, right? Their intake, okay, design, it's very similar to them. So it has that like level of expansion so that I can do both the small and the big balls. Okay, so pneumatics do the launching. Yep. So one thing that I think might be better about this robot in comparison is it looks to be a little faster on the lift. Look at it. It'll go up. It'll pick up the ball very quickly. You can hold 2 at the same time. So, that's an immediate, you could launch 2 and do a 5-point swing. And the lift seems to be so much quicker than the scissor lift, right? So the down to up motion seems to be a lot faster. So we've identified that, if all you're doing is stashing balls, then you want to be as fast as you can about doing that. And so perhaps the decision to make a scissor lift, although effective because it could start at 11 inches and then get to the correct height, is maybe a little overkill. Maybe it's too slow. So in this sense, we can see which robot is better than the other one just because they're a little faster. Additionally, it looks like, using the tray backwards to hang might be a really smart maneuver there because it's just a passive hook that hooks on, right? Your lift has to be strong enough to lift your robot and strong enough to lift the objects. So maybe do some heavy consideration into, doing some weight analysis, making sure that your weight is not too heavy. If this robot had, that passive mechanism to knock the ball off the barrier, I would go ahead and say that this is objectively better than the previous robot we just saw, right? And boom, making quick work of that. So good video to watch. Good. So like we're noticing, the ideas we had about, making sure that our intake can expand, making sure you can go into the barrier. These are valid ideas that other people had, other people like thought of. So that's a lot of this game going back and forth. We can let's see if we can quickly squeeze a match in, and then we're gonna call it good. So we're
29-15.
We're talking our world's finals. What do you got? Spurflies, 21.5C, 8,000. All right, so Autonomous begins, and you notice the same thing. So they decided to split, send one robot to the front, one robot to the back. Looks like someone's Autonomous missed. But what they did was they picked up one of those beach balls, right? And then they aimed them at the other beach ball so they can knock multiple on the way down. So you didn't even have to, be there to knock those beach balls forward because they expect those projectiles to go. So that's, a good usage of time. Let's see, Autonomous being tallied. So getting that Autonomous bonus is pretty big. They said 10 points there. That's the equivalent of 2 buckyballs in a stash. So, that's going to be a good kind of maneuver to have. Okay, so we go on into our driver control. We'll notice that the blue robots are right there. They're spending all their time getting the buckyballs to the front. But in that time, the red robots have taken the stash over. Although the blue robot has 6 buckyballs they can score, there's physically not enough space in that stash to score those buckyballs. And so it's very, very advantageous to get your buckyballs in the stash first, right? Because they can't be taken out. It's guaranteed points. So the red robot is going to actively hold that blue robot there. Looks like they're kind of stuck, but the robot is actively, saying they could back up, but if they back up, they're going to give that blue robot the opportunity to score. So they want to kind of aggressively hold that point to make sure they maintain control of that stash. And you see the other red robots doing the same thing, right? They own the stash. And although the red robot could take that, go to the back and take a red ball and toss it back over, they're actually just going to prevent their opponents from scoring in the stash because they recognize that, the opponents are going to spend a lot of time trying to get those 5 points, but in that much time, they're also burning time. They're not scoring more points. So the red is making a smart play here to kind of just strategically hold. All right, so red goes out of the way. Now we've got 2 red robots there. Blue robot takes advantage, gets a buckyball in while the red one was distracted. Red goes in, and they physically, they can try and score that, but it's going to be very difficult with the blue robot playing defense and the blue robot having their buckyball already in there, right? So now we've seen that the stashes are essentially filled. Now you're going to see a lot more of them tossing those big beach balls back and forth, right? Because once those buckyballs are scored, see those buckyballs in the back, they weren't even touched because there's no point now because all of the buckyballs are already in the goals. There's 3 potential buckyballs there. That's 3 per color. So, you already know that they weren't focused on those because they knew they could get the stash early. And then boom, last second hang. So, being able to use the mechanism that you used to launch to double function as a hanging mechanism, super advantageous here. So that was a little briefer than we normally do, but we are running really short on time. So I'm going to have to definitely stop it there. But, we're totally good to do some Q&A if you want to do some. If not, thank you guys for coming out to the session. It was great. Thank you, Nate, for helping us out here today. Hope you guys will join us next week where we'll continue to do this type of thing. But yeah, thank you guys. If you guys have any questions, I would love to answer them. So feel free to ask away. Who won that match? Let me see if I posted the score actually. Toss-up finals match 2. Let me see if yeah, see, by 1 point, the Red Alliance won that match. So, taking advantage, and it's a really tight margin, taking advantage of the early scoring, super big. The final score was literally 64-63. So the fact that the Red Alliance ignored, those balls in the back, and they ignored them until, very late in the game, they knew that if they got that stash early, the blue lines couldn't fight back. Yeah, so if a blue had gotten their buckyball stash, it would have swung blue. And that's a great point, right? So that means that what we saw was the red made the correct decision in holding the blue lines there. Instead of backing up and, going to score more points, they knew that they were ahead and they can just lock in their lead by preventing the opponents from scoring because those things, once they're scored, can't be unscored. So really tight margin, but, correct decisions were made in that play. So it's always about identifying, what can you score and what can you prevent other people from, what points once you score are kind of guaranteed, right? Those buckyballs, once they're stashed, guaranteed points, can't take them away. In my opinion, what's the best way to make an autonomous more consistent? Okay, so autonomous consistency is huge, and I think that it defines the difference between, a robot that does okay at states and a robot that does great at worlds, because that autonomous is what puts you ahead. And especially with this year's this year's game was with worth so many points. I think consistency is definitely key. The way you achieve that consistency is, 1 through iterative testing. So, make sure that you are testing just every single bit of code you add, whether it be a turn, whether it be a forward, you test that step by step. And then also understand the speed at which you're doing that. Often, because we only have 15 seconds to do those autonomouses, we tend to punch hard, but the punch doesn't connect because we're going too fast. So I normally for my turns, I slow them down a little bit so that the robot doesn't have that extra drift. I also try and understand, what are mechanical errors versus code errors. There are times where we get like mechanical errors. The wheels just have so much slop that they fall off track or they're not super in line. There are other times where the code literally is just the wrong number, and it happens. Identifying which one is going to be great into doing the testing. I would also say, make sure you tune your autonomouses, make sure you test on multiple fields if you can, and make sure you're meticulous in the way you set up your autonomous. A perfect example I can think of is in the state of Virginia, right? There is, who is it? Kronos. I forget his number, but like Kronos is so meticulous in the way they do their autonomous. Every autonomous, they'll pick up the robot and, they'll put it on the tile, they'll move it forward 1 foot and backward 1 foot. And the reason they do that is so they can get the slop out of the motors, right? So doing that motion kind of makes sure that as soon as the motors start turning, the axle is engaged and it'll turn. So they get the slap out. He's got a tool to help him align on the tiles. So he's not just relying on, it looks kind of lined up. He uses a hard set tool to align him. Additionally, he's, thank you. Yeah, 56736C. Super good about it. He's like so meticulous, and I love the way he does it. It's called backlash. Cool. Didn't know there's a term for it. But yeah, so backlash is apparently the term for that. But yeah, it's super meticulous, right? Very helpful. I would also recommend that, if you're trying to get autonomous consistency, then you look into, what does your code do that you can do a little slower? What does your code do that you can do a little bit more precise? So I always use, sensors and everything I can. In terms of like testing consistency versus like straight up writing consistency, I always if I'm trying to get a consistent autonomous, I make sure that it's that I know what time marker what's supposed to happen. So I know that if I have a run, I have some sort of safety. I know that if at 10 seconds, this autonomous isn't at this point, that it will not finish or something will get messed up. And at that point, I can identify, okay, what caused that failure? That type of realism. Using stuff like PID helping you a lot in the past, but they tend to be a big time. Yeah, so PID, super useful, but it's a big time commitment in terms of tuning and getting down to like exactness. I would recommend if you're going to use PID, go for it. It's super helpful. I would also recommend that you don't burn too much time on consistency, on PID tuning, really. I've seen teams burn like literal days on PID tuning, and it did not help them much, right? So if you're going to go with PID, go for it. And, try and look up a video how to tune it. Definitely so like what I normally do when I'm tuning my PID is my P constant goes all the way up until I see oscillation along the completion line, right? So the P is the oscillation that I should get. So if my P is too small, then what will end up happening is my robot will not achieve the final distance. If my P constant is too large, what I'll notice is it'll pass the distance marker, but then go back and then forward. And it'll start kind of oscillating along that distance line. So once I see that oscillation, I slowly start dropping my P constant so that it can just barely get there, right? Or just barely not get there. And then once you've got the P, add the D constant and just add a little bit of derivative constant so that it can kind of glide into that final number. The I you almost never need. So like, I don't know, PID, the I is almost never needed, but yeah. Oh, George Gillard, yeah. So that's a great PID controller. You definitely want to read that document. Get a good look at that because that's a great way to kind of start. But autonomous consistency, all about the amount of practice you do, and try and identify, what is the range of try and identify what the range of consistency is on your autonomous. If your autonomous is always set up like this, sometimes try and set it up a little to the left or a little to the right and see what you end up getting, right? You can identify how tight your autonomous really is in terms of, what its failure points are. And you can then try and either design something for that, such as, having some sort of like alignment rig to help you be straight every time. Or you can identify some sort of methodology as to, oh, every time I need to set up my robot, I want to get rid of all the backlash, as I've been told it's called. Or you want to make sure that all your sensors are there. I have a checklist that I go through for autonomous to make sure that everything is there. I check it twice, make sure, and then use a tool to make sure that my autonomous or my robot is in the correct position. And like in the code, I'll have watchdogs to say, okay, if doing this motion took more than 2 seconds, stop the autonomous. It's going to mess up. Yeah. So I hope that kind of answered your question there. If not, feel free to shoot an email and I can definitely, maybe address it again or whatever it might be. Yeah. Any other questions I can answer? All right. Well, I mean, that's fine. We don't have to have questions, right? So if everyone's on the same page, thank you again for coming out.